Hi, I am Remy Selvi, MR Storage Business Development Director. I will have the pleasure to interview Kelly Smith, our Senior Principal Product Manager at Oracle. Kelly, to start with, we can say that 95% of the business today is digitalized. Therefore, we need to protect, all these transactions 7 days a week and 24 hours a day. And we must also make sure that the most valuable assets of your company, the data, are also protected against new risks like internet attack. Am I right on that?
That's exactly right. Thanks for having me today. Digital data is very important. Losing transactions and data impacts productivity and really damages the reputation for the company. Recovery, if we think about it, is very different today than it was 5 years ago. RTO is shrinking. People want to get their data back as soon as possible. RPO is becoming critical. We need to get to every single point in time to recover data. Also, internet attacks have increased. And if we look at the downtime that's associated with those internet attacks, we're looking at more than 16 days of outage. And for small businesses, that's $8,000 an hour on average. Large businesses, $700,000 an hour. So when you do the math, that gets expensive very quickly. And unfortunately, at the end of the day, there's 3% of data loss that happens during one of these attacks.
And is there a way to protect the data against these internet attacks?
Yeah, so there are lots of ways to protect the Oracle database. Today, I'm going to focus on the Zero Data Loss Recovery Appliance. And really, there are two primary levels of protection. One is making the recovery appliance as as least visible as possible. The other is the recovery appliance unique capability to restore the database up to the very last transaction. So the recovery appliance itself was created by the database team. There's a tight integration between the Oracle database and the recovery appliance, and we understand all the database internals to make, the protection as performant as possible and as efficient as possible. So that means you get continuous data protection, you get sub-second RPO, and you can restore to any point in time. Retention is important for your organization, and we want to do that with the least amount of capacity possible. And really, you want fast, predictable recovery. So you want the best RTO possible, and that's what the recovery appliance provides.
And Kelly, can you tell how ZDLRA can help against ransomware through a specific example?
Yeah, so let's talk about the anatomy of an attack really quick. The attack starts with a bad actor, targeting your company with phishing and application manipulation and trying to go after unpatched systems. And their concept is to try to retrieve credentials because once they have credentials, they can search for specific data and then they can spread themselves around your infrastructure. And they will spread through both your production infrastructure and they'll look for your backup applications so they can disable those. So when they do the ultimate activation and payment request, you have no way to get back. The recovery appliance is going to be less visible and provide you with the capability to get to that transaction that occurred just before the attack happened.
But don't traditional backup solutions today keep your data safe against this type of attacks?
Let's talk about some of the problems with traditional backup applications. One, they use common communication and file transfer protocols. We're talking about CIFS and NFS. Been around a long time. Most people have a deep understanding of how to attack those surfaces. Also, the credentials that are stolen are common to be, it's very common for those to be used all over the enterprise for backup and other operational activities. So that means that the backup becomes part of the compromise. Backup files are visible and they're easily destroyed, easily manipulated. And finally, because they're easily visible and they're compromised along with production, that means that the backup application is also disabled along with the production infrastructure.
And in that case, so how can ZDLRA help?
So the recovery appliance As I mentioned, there's tight integration with the Oracle database. It's using strong authentication, and it's not using traditional communication methods. It's using communication methods that are built into the Oracle database, and that strong attachment reduces our overall attack surface. The data itself is partitioned inside the recovery appliance, so each database is stored in its own individual location. And the hardware is designed to be redundant, so there's no single point of failure. The files, when they're actually aren't stored as traditional database files. They're stored as in a relational database structure. So it's more of a camo effect for the backup files themselves. And then, of course, if you're talking about security, you're also going to be talking about database encryption, which involves TDE. And that means that the production database is going to be encrypted. The data that's in transit will be encrypted with TDE, and the data that's stored in the recovery appliance will also be stored encrypted. And then finally, if you're going to be talking about security and cyber protection, you want to look at actual blockchain tables inside the production database.
It looked very promising, but can we see a small demo of how it works?
Yeah, let's do that. So I have a demo of the capabilities of the recovery appliance and its ability to recover from a cyber attack. So let's roll that video. I'm going to do a demo that shows point-in-time recovery using the zero data loss recovery appliance. What I'm basically going to show is I'm going to show how the database protection is configured on the recovery appliance. Then I'm going to load some data into the protected database so we have real transactions coming into the database. I'm going to simulate a database failure, and then I'm going to do a point-in-time recovery from the recovery appliance that will actually show that the last transaction was captured from the database. Think about how powerful it would be to get to that last transaction in the case of a ransomware attack. Some of this is pre-recorded because obviously data movement takes time, and I don't want to bore everyone while we just watch data move around the system. So first, let's look at the database. This is a single no database, no data guard, anything like that. You'll notice that the database, the one at the bottom, is protected with real-time redo, which means that every transaction coming into the database is being protected. Now we're going to start a data load. Now we're at about 7,700 megabytes of change per 10 minutes, multiplied by 6, multiplied by 24 hours. So data is coming into the database right around a terabyte per 24 hours. So you've got a lot of change occurring on the database. Things are happening really fast. There's a lot of transactions coming in. In our world today, where ransomware hits customers around the globe on a regular basis, the thought that hits your mind at this point is, okay, the database has just been attacked. It's been encrypted. I don't have access to it. So your first thought, of course, is let's go. I've got a backup. I can just go to the backup. But when was the last backup completed? Was it 15 minutes ago? Was it an hour ago? When you've got data changing at a rate of 1 terabyte per day, that could be a lot of transactions for your organization. With the recovery appliance, because as I mentioned before, we're doing real-time capture of the data as it's coming into the database, we can simply go to RMAN and tell RMAN to get that last transaction, that last SCN that occurred. And that's kept track of in the recovery appliance. So first, what we're going to have to do is we're going to have to tell RMAN that our restore point is going to be that last SCN. So we're going to add that into our RMAN script and tell RMAN that we want to go until the SCN, which is the last SCN that was protected on recovery appliance. So we take that SCN from the recovery appliance, we put it into our RMAN script, we're ready to restore. Now restore starts from the recovery appliance. So in the case of, this cyber attack, it's very easy to set up a new server. Let the old one go to the forensics team to figure out what happened that allowed the cyber attack to come in. We can go to a brand new server, bring up the server, and restore the database to that last SCN. So the recovery appliance is doing that now, right? It's gathering all the data from the backups, sending it back to the database that you've now stood up, that's clean and ready for recovery, that isn't infected with ransomware. And now the database has been recovered, and obviously this was a simulation, so we have the added ability to go back and look at the previous database to figure out where it ended. So now we can do a comparison, right? We've got the database that we just recovered. We've got the original database that we just actually did a shutdown on. And you can see that the transactions that existed on the old database and the transactions that are on the new database, when you do that comparison, that is zero data loss. So data was captured up to the last moment that that database was online. And now you know you had a safe spot to go back to in the case of a cyber attack. Thank you for watching the demo today. I hope it was valuable to see the power that the recovery appliance could bring to your environment.
Good video. So are there other ways to protect the data against these attacks?
Definitely. So let's start with the basics. You want to have proper account management and access control. You don't want to have a common account that's being used across multiple individuals inside your infrastructure. You want to make sure each person has their own specific credentials that have proper access. Not everybody needs to be a SysDBA. Next, patch management. Make sure your systems are patched up to date. A lot of the attacks that are occurring have occurred most recently are the result of unpatched systems. Have a recovery run book. You don't want recovery from a cyber attack to be the DBA's on-the-job training. They need to know exactly what to do and exactly what the results are going to look like. And then finally, make sure that your employees are ready for a phishing attack. They need to understand how these attackers use a socialization method to try to obtain access.
Good, but in such a cyber vault architecture, why is ZDLRA so effective?
Yeah, so let's talk about the basics for the vault first, and then I'll talk about the specifics for the recovery appliance. The vault is designed only to store your critical data. Second, it needs to be self-contained and automated. You want to make sure that this process is happening on a regular basis without manual intervention. Third, limit your access control. So even more limited than production, there should only be a small number of people that have access to the vault. Finally, the vault should remain disconnected. You want limited connectivity between the vault and the production systems because you want your vault to be your fallback location. And now if we look at a sample architecture, we've got Data Center 1 and Data Center 2, which is providing you high availability and business continuity. And you've got DataGuard replicating data between the two data centers. And for non-data guard systems, you've got the recovery appliance that can also do replication to get the data offsite for business continuity. The databases are being protected in real time. Every transaction that lands in the production database is protected by the recovery appliance, so your database protection is always up to the last transaction. Enterprise Manager is giving you a rich understanding of exactly what's happening in your infrastructure, reports, auditing, and alerts. You want to make sure that you understand exactly what's going on. Now let's add a vault into this architecture. Now the database can be randomly replicated into the vault. The vault is controlling this replication. You don't want an attacker to be able to set their watch by when the vault is going to connect to production. The vault should be controlling that on a random basis at a random time. You'll notice that there's an enterprise manager inside the vault. The enterprise manager, again, is going to give you a rich understanding of exactly what's happening through alerts, reporting, and an audit trail so that you know exactly what changes have been made and when. And then finally, there's a separation of management. The production database administrator should not have access to the recovery appliance in production. The production recovery appliance administrators should not have access to the recovery appliances in the vault. All individual accounts, all separated. So from a benefits perspective, the database is being protected in real time. the very last transaction can be retrieved. The database backups are being independently validated, both in production and in the vault. So you know the backups are always ready for recovery. Auditing and real-time reports are available through Enterprise Manager on both sides. Access control, individually siloed for production databases, the production recovery appliance, and the vault. Access management is controlled individually. You should not have readily available access from a management perspective into the vault. And the vault can be restricted down to the individual backups that are required if a recovery is necessary. And then finally, again, if you're considering security and protection of your database encryption, TDE should be right at the top of your list. That has no impact on any of these capabilities for the recovery appliance in the vault.
Thanks, Kelly, for these very interesting presentations of the ZDLRA infrastructure. So basically, to summarize, ZDLRA do not prevent the rest of the enterprise from being compromised by malware, but it will protect the mission-critical data from being ever targeted or affected, and it will reduce the risk of losing this data. Oracle has hidden the ZDLRA by reducing its exposed surface, masking its architectures, and increasing its resilience, making it practically impossible for direct ransomware attack. So I thank you for the audience, and I wish you a very great day.